Hello, my name is Joel Anglister, and in this video, I'll be talking about debugging tools and techniques that are helpful to use when your code isn't working and when you're trying to figure out why. As we go through the list of techniques, you might find that you already are familiar with some of these techniques, or some of you may not be familiar with any of them. Either way, after watching this video, you should have a basic understanding of what you can do to debug your program the next time you're working in your IDE. I'm going to be using VS Code, but other modern high-level IDEs should be comparable. Good? Let's get started. Think about the last time you were frustrated with your broken code and ponder the following questions. Why didn't your code work? How long did it take to fix? How did you fix it? And finally, do you wish you had solved the problem a little bit faster? I'll give you a little bit of time to think about these questions. I really want you to think about the process that you went through in order to fix your buggy code. I'll pause for a few seconds. Did you think about it? Good. Now keep that example in mind as we start discussing the debugging process. Let's start by discussing the most simple debugging tool out there, the print statement. When we all first learned to code, we used the print statement as a measure of how far we got in the execution of our code in the case that it crashed unexpectedly. We also used it to inform us of the values of our variables before we learned other ways to figure that out. For a very simple debugging tool, we'll use a very simple example to demonstrate how this tool may be used to help us debug our code. Let's say we have a method like this that takes two numbers as input from the user, divides them, and prints the result to the console. Let's suppose the user inputs the numbers 15 and 5. As we can see, the program correctly displays the number 3, which is 15 divided by 5, as expected. However, as the more advanced programmers among you may already know, there's a potential for a catastrophic runtime error here. Let's suppose the user inputs the numbers 5 and 0. As we can see, the program crashes and tells us what the issue was. Now, not every language and IDE supports this, so let's pretend for the sake of this video that we didn't see this detailed message, and let's use print statements to try to figure out the problem. Since we are choosing to ignore the error message provided to us, or at least pretending we don't understand it, let's start using these print statements to figure out what went wrong. There is a limited amount of lines of code here, so hopefully it shouldn't take too long to figure out where the problem lies. However, with more lines of code, it might take much more print statements and it will take a longer time. I'll simply put the print statements on these lines, choosing prompts that will give me hints as to what is happening in the code. Since there is a print statement after every successful step in the code's execution, we should be able to deduce where the error lies by looking at the last print statement that executes. This will tell us that the error occurs on the line directly after the last print statement that works. As we can see from running our code again with the same inputs, our print statements help us understand the code execution process and where things may have gone wrong. Our messages tell us that our method executed and we successfully retrieved both integers, but the execution terminated before we got to the print statement that would have informed us of a successful division. Because of this, we now know that the bug occurs when we execute the division, and this gives us much bigger insight as to how we can approach the problem. From here, I'll leave it as an exercise for you guys to think about how you might solve this problem. I'll give you a few seconds. Now let's move on and talk about a more sophisticated technique that is included in most high-end IDEs, which is the use of breakpoints. Breakpoints, like their name suggests, allows you to break the execution of a program at a specific line in order to gain insight into the program's ins and outs. To demonstrate this idea, let's look at another simple program. Take a second to read this function and try to understand the flow of the program. The program's goal is to reverse the digits in an array of single-digit integers. As you can see from the parameters on line 11, we pass in two arguments, the array and its initial size. If we try to reverse the digits 0, 8, 3, 2, for example, we want an array that contains the digit 2, 3, and 8 to be outputted, without the 0 at the end, since 0, 8, 3, 2 should be interpreted the same as 8, 3, 2. However, when we try to execute this program, it crashes, and this time the error may be a bit harder to spot and fix. To solve this problem, we'll put a breakpoint on line 11 by clicking the red dot next to the line number so that we can follow the code execution from the very beginning. During this process, we will use the buttons in the IDE to navigate through our code and look at tabs on the left that will guide us through the process. Please follow along. Now, from the Run menu, I'm selecting the Start Debugging option, which will allow us to actually stop at our breakpoint instead of running the code normally. We now have access to this menu of buttons that helps us navigate our code. The third button allows us to step into our method to investigate it. After using the second button a few times to step over the while loop, our screen looks like this. The yellow arrow indicates that we are about to execute line 6, and the Variables tab on the left-hand side of the IDE tells us the values of our local variables. Already, we can see that the reported size of the array no longer matches its actual size, but this doesn't yet solve our issue. After using the Step Over button a few more times, we get to the following position. Our increment variable I equals 3, and we're about to run line 8. Let's see what happens when we click Step Over one more time. As you can see, the IDE now reports that an index error has occurred, and with the use of the breakpoint and stepping through the program, we are able to see exactly what are the values of the variables that may have caused this issue to pop up. As we can see, the list ARR only has 3 elements in it, but we are trying to access the value at index 3, determined by the increment variable I. Because we previously deleted an element from our list, when we try to access the array at index 3, that no longer exists, which is why we are getting this error. Good to know. Now I want you guys to think for a few seconds about how you might change this code to address the issue at hand. Those of you who are well-versed in Python may know of a single line solution for this method, but just try to think about removing this one bug instead of rewriting the whole function. I'll pause for a few seconds. Okay. Now, with our previous knowledge, we can now adjust the code to address the issue. If we remove the size parameter and instead base our for loop on the length of ARR based on its current length, as determined by the built-in function len, we can run our program again and observe that it works as intended. When we pass in the single parameter 0832, our program successfully outputs the array 238, which is what we wanted in the first place. In conclusion, print statements and breakpoints are two very simple techniques that you can use to debug your buggy code. Using breakpoints is almost always preferred because of the control it gives you and the time it saves writing print statements and deleting them. Breakpoints keep your code just as clean while delivering the same results with even more information. It's important to keep in mind that today's presentation just focused on one specific environment, and that if you are trying to debug your C program on a Linux terminal, for example, the process would look very different than this. However, that's a whole other can of worms and probably deserves its own video. Anyways, that's all for today's presentation. Thanks for watching.